Please welcome Katerina.
Hello again. First of all, it's a pleasure to be here again. I can also say that this is the most amazing community I have ever been part of, and you're all always so welcoming, so thank you for that. So I want to speak about team performance and how each of us can help improve the performance of our teams, regardless if we are in the team as individual contributors or as engineering managers or have some leadership role. Just a bit of a background about me. Kaneko told me I'm always kind of in the background, and he wasn't sure what to share, so I can just briefly tell you a bit about myself and why am I kind of exploring this topic from different angles. So I co-founded Adiva in 2014, and since then I have been working with various companies and various different teams, so oftentimes filling their pain points at different stages. Adiva is a platform for consultancy work, so people that are looking for contracting opportunities and companies can connect. So we've been helping a lot of enterprises and startups alike. And there is something very unique that combines the two worlds, which is the approach towards developer experience, organizing the code, working on team performance, and focusing on metrics and things that can either improve the performance of the team or really reduce it. And that's the thing that I want to explore today from an angle of an engineer that I am and an angle of a leader that I've been throughout the years with various teams. The first thing I want to do before we start is just a quick quiz for all of you. So I want to see how does your work environment affect your productivity. So if you can just open that link. Okay. There's some really healthy companies in the audience. So a lot of people work in an environment where most of the things work smoothly, which is great. The context switching is one of the biggest things that impact the performance. Let's see now. What is the, like if you should name one single thing that affects your performance, what would that be? Meetings is by far the biggest one. And useless meetings, okay. That gives us the idea. Okay. So I've spoken to a lot of people on this topic, and I tried to summarize most of the things that I have received as answers, and they kind of fit with what you were just saying. So negative impact on performance, most of the time, context switching come as the first one. And this is meetings coming in here, planning the working day in a way that you need to go to regular meetings, and they don't have a fixed schedule, so they kind of constantly interrupt your work. But this also goes into a direction of not having optimal tooling, or having your tasks running for 50 minutes, or things that, you know, are kind of forcing you to find a distraction and do something else while you should be focused on development. The second thing, which didn't come out here but is very common, is lack of big picture. And oftentimes companies fail to communicate the big picture with the teams, so people don't understand what is the bigger impact of the thing they're working on. And this is not only affecting the team morale and the motivation, but it's also something that can contribute to future performance of the team. Because if you are not sure about how the feature you're developing should work in the longer term, then you will opt in for a simpler code design or for a quick fix that could come back to you later and make it much more difficult for you to navigate through the code base. And then we have bad quality control. So this is lack of automated tests. This is relying on the QA team too much for handling the quality control side and testing the functionality. And finally, bad code, which is something that we've all had to deal with at some point in our lives. And the thing is that measuring lines of code cannot improve team performance, and this is something that a lot of managers rely on because it's easy to measure. So we talk about measuring lines of code as a metric of team performance, or we talk about bugs that have been found, which can be metric of good performance for QA, but metric of bad performance for developers, and things that are kind of inputs and are very easy to measure, but not only not give the accurate picture of the performance of the team, but they also demotivate the team from doing work that matters, like cleaning up old code or removing more than you have written and so on. So what are the things that we can do to improve the team performance actually with our metrics? And this is focusing on qualitative metrics that can actually help us understand the health of our team and what are the things we can do to improve it. The first thing is regular performance evaluations. So we've had a lot of cases where there is a single person on the team carrying out all of the heavy work, and then 6 others working on smaller tasks which are at the same level. So this can be frustrating for the individual, but also not productive for the team. And oftentimes managers don't realize this. So what all of us, like if there are any managers and in the audience, you could directly implement this, but for all of us that are kind of on the individual contributor side, what you could do is raise your voice and talk with your managers that there is something that needs to be done. If you don't have performance reviews within your company, ask for them, talk to your managers about the expectations from your role, the expectations from everyone else's role, so that you can align better and give better input as an individual so that you can improve the overall team performance. Then this one is very interesting, and it's a metric of the percentage between strategic and tactical work, or feature work and bug fixes. And it's something that can highlight the performance of the team very well, because if you are focusing too much on things that are tactical, or you're fixing bugs all the time, or you need to navigate through the code for long to just maintain a simple feature, these are signs of bad code design, of tech debt that you need to focus on. And to managers, it can also give a clear idea what they can invest in if they understand the impact of the code design, because most of the time they don't. And we have the context switching here. This is a bit more difficult to measure, but if we focus on the schedule of the meetings, or we focus on Jira tickets and how many people work on at the same time, how is the day organized basically? And this can be also done through one-on-ones with the team, and you again raising your voice to explain the consequences of this issue to your managers. This can also affect the performance of the team a lot, because you can manage your time better. Aside from these kind of softer things that a team can work on, a very nice kind of matrix of measurements that has come out of Google's research are the DORA metrics. So they focus on 4 things, they highlight 4 things that are very relevant for all teams and that are showing the quality of the delivery performance of software teams. So you can see here we have elite and low performance. And it's a scale, so the performance of the teams varies in every stage of this. We have low performance that deploy fewer than just 6 months, and then we have elite performance that deploy multiple times a day. So based on your responses to the quiz earlier, I assume that, and based on the talks and everything in the community, the quality focus over here, I assume that a lot of you are focused a lot on the quality of work and implementing continuous integration and everything. But I've been working with a lot of teams, and these usually come on the enterprise side with legacy code, where they have release deployments every 6 months, and then they have a code freeze for a month. So for a month, you're not allowed to deploy anything, to merge anything into the main branch. And this is causing a lot of conflicts, a lot of issues, a lot of regressions later on, and it's affecting the performance of the team a lot. So the most important thing when we look into this is to locate ourselves on this scale and say, okay, what are the things that we can do to improve our performance? We don't need to strive to become an elite performer, as they call it, but there are things that each of us can improve in our day-to-day work so that we can perform better and have better software delivery. So what can I, as an individual, do? The first thing to do is to transfer quality ownership from QA to developers. And again, in traditional teams, it's far too common to have teams where there is a developer, there is a QA, and every ticket is manually tested before it's ready for deployment. And then we have this scenario. So the developer works on something, oftentimes not even focusing on the quality of the ticket and whether all of the acceptance criteria is satisfied because, hey, there is someone I can rely on to check that for me. Then the QA finds a bug, returns the ticket back to the developer fixes it, goes back to QA, everything goes well, they agree that this has passed, and it goes to the main branch. Now, what happens when the developers own the quality? We have the developer writing the code, and then it automatically goes to the main branch, because there are some ground rules in place that allow this to happen. And all of the most highly performant teams are following these practices and setting up these practices, because even though it is an investment upfront, it reaps a lot of benefits on the long run. So, as I said, we are all falling on different places on this scale, and to say implement continuous integration is overwhelming to some teams. So what's most important here is to identify the current state of the team and find out what are the things that you can do to improve your overall performance. So if, for example, you have a lot of back and forth with open tickets, that's where you can focus on. If you have additional issues later on that you should focus on, like improving your test coverage so that it can take less time to go to the main branch, then that's the thing that you need to focus on. But finding your space and finding the things that you should focus on is the most critical first step. Then incrementally increasing the test coverage. We've heard a lot about this already, so I'm not going to dig deeper into it. Practicing test-driven development for all of the new features. And finally, adopting continuous integration. But the most important thing is that this is a step-by-step approach, and it's not something that you can do from tomorrow on. Now, the big question is how to write tests for untestable code, because we've all heard a lot of good practices about writing tests when we start from scratch and we have full control of the code base and everything. And in an ideal scenario, we would have time allocated for testing our code whenever we work on something. But what if we have inherited a code base which is very complex and coupled, or we're just joining a project and we're uncertain how to navigate through it? How do we write tests for this type of code? There is a thing called characterization testing, and the purpose of it is not to test your code so that you can find bugs and understand the performance of your code. It's more like for documenting purposes and for understanding what your code base does. So what happens with characterization tests? You basically start with something simple. You are not sure what the program should return, and then you test for it. There is an interesting suggestion over here from Michael Fetters, who is the person who introduced characterization testing first, and he suggests starting with a test named X, because this is kind of putting you in a mindset of curiosity where you don't know what this code does because it's legacy code. You just found yourself in the middle of it, and you're now trying to understand what the code base does. So starting with a test X basically allows you to not know what you're doing. And you can just, over here, I'm testing some payment class, which is handling different types of payments on our platform, for example, and then I need the payment details for the person that needs to be paid out, the amount, and I'm just verifying the response of this method. This would fail, and when it fails, I will actually see the actual response from this part of the code. So this helps me understand what it's about, how does it work, and then go back to the tests and work on them more to make the whole coverage better. So I can just play with it after that, like change the Swift code, change the account name, remove something to see what it does, and these experiments will help me understand more the whole code base and how this part of the code works. So you could just, from here on, write some more tests, and again, don't worry about doing it the right way. It's just, the purpose of it is to have some sort of documentation of the current state of your project, which can help you later on refactor it with some sort of a safe net, and can also help you understand the functionality better so that you can work on new features after. So this is my test X, which I renamed to Successful Wire, because right now I understand what it does. And then it passes. Now, what happens if you're testing something more complex and your method is returning a view or something else happens and you're not sure how to assert that response? There is a nice package from Spatty, matches snapshots, and this is snapshot testing. So basically what you do here, when you first run the test, you can see, I haven't highlighted, at the bottom here, there is this assert matches snapshot, which is basically creating a snapshot of your response, storing it in a folder somewhere, and then every time you rerun the test, the response will be compared to what you have in your snapshots. So this is a nice way to just cover your tests with, cover your code with tests when you are not sure what exactly it returns and how you can navigate through it. And of course, the process later on from here is the same, because you start to understand more about the structure of the code, what are some other scenarios you can try out, and then improve the test coverage, add all different cases, and later on refactor it based on that. The second step that you can take as a developer to improve the whole performance of the team is to improve the developer experience. There were a lot of talks around this, and it's very intuitive when it comes to how you structure your code, because the way you write code today will directly affect your performance in the future. If you invest a bit more time today when you work on something complex to outline it properly, create a nice architecture, and work on it a bit longer than initially planned, that could have a lot of benefits on the long run, because it would mean maintaining it in far less time. On the other side, if you decide to go quick this time and not focusing on any good practices for designing your code, then it will backfire later on, because you will need to go back to that part of the code and try to fix something, break something else, and so on. So what does this mean? It means that we should always write code that's easy to extend and maintain. And as you might know, I'm a big fan of the solid design principles, and I will focus on how using them in more complex applications can help us structure the code in a way that will make it easy to maintain and extend. I'm using an example from our platform, as I mentioned. So over here, this is the account settings page of a contractor profile, and you could set the payment details. So we have Payoneer and wire transfer as options, and now the question is, how do we scale this in the future to enable multiple payment options without having to redo everything over and over again? The first step is organizing our code for readability and easy navigation. And when I say this, I think about the interface segregation principle and the single responsibility principles in Solid. So what this means is that we start with creating interfaces that are small and specific and that exactly show the purpose they serve. So that when you read an interface, you know what it does and what you're supposed to cover there. And then every method, every class of your code should have one responsibility and one reason to change. Following the interface segregation, so implementing small interfaces can guide you easily through this process, but you also need to be careful about all of the responsibilities that your classes handle. So if you think you're having too much within a single class, then you likely need to distribute responsibilities elsewhere. So in code example, this would look something like this. We have payment option interface, which is basically outlining some main methods that I want to have, and these are all connected to payment management. So we have getting the fields dynamically so that we can display it properly on the front end and make it scalable, everything else related to managing, saving, deleting payments. And then this might be hard to see from the back, but it's basically a class that implements this interface. So I have a class wire that implements the payment options interface, and it has all of the methods outlined here. And I have the same for Payoneer. So an interface which is small and simple, and two classes that are following it. Again, small and simple, easy to understand what they do because they are structured in a proper way. The second part would be depending on abstractions, not concretions. So the thing here is that we want to replace all of the dependencies on concrete classes with dependencies on interfaces. This will make it much easier to test, it will make it much easier to abstract the dependencies, and much easier to maintain and scale the system in the long run. And one catch here is it's covered by the Liskov substitution principle. The thing is that whenever we use classes that implement the same interface, it's often overlooked what they return. So we need to be very mindful about this and make sure that all of the implementations of the interface that we're about to use interchangeably actually implement the methods in the proper way. And you'll do this with your tests. Now, this would be our controller. Basically, I have the two classes, wire and Payoneer, and depending on what the user selects in the front, I am using an instance of the proper class to call the proper method on it. So it's either wire or Payoneer, and then I call the method on the right object. When you switch the dependency, you would basically depend on the abstraction or the interface. So over here, we are replacing that with the payment option interface and directly using that in our code. So our controller now doesn't have to care about who is handling this in the background or what our code is structured, basically, because it knows that it has an interface to rely on. It's using that interface to get what it needs to get, and then everything else is handled in the low-level modules. And this is the thing that we would need to add in the service provider. So basically, depending on the selection of the user, bind the proper instance of the class with the interface that we're using. Now, I'm sharing this final, even though it's the O in Solid, the second principle, but I think it's covering very nicely all of it and all of the preparation work that you need to do. Add on change, it means that whenever you want to extend your code with new functionality, you should add new code instead of changing existing one. And you can think of open source libraries for this purpose, for example. They are changed very rarely. Everyone who uses them in the context of their project, so code is added on top of them. So any open source package that you use ends up being so well tested by so many users, and on the other side, the core of it is not changed as often, which makes it very robust and over time very resilient to bugs. We want to achieve the same within our own code. So what this means in our case, we open for extensions, closed for modifications, and yes, adding new functionality by adding new code. Imagine we need to add another payment option, let's call it Wise. And then what I need to do is create a new class that will implement the same interface, have all of the methods outlined there, and then go to the service provider, assuming that everything was done in the background, like database and all of the needed things to adapt. I'm just connecting the interface with the new class, depending on the user selection. So what this helped me is to extend my code with new functionality without touching any of the existing code, and by adding new code that can be tested and written by following all of the best practices regardless what I did before. On the other side, good code design depends on the context of your project. So good code design can also be this. And we heard about it a lot yesterday. If your project is simple, and a lot of them are, you don't need to focus so much on adding this extra complexity, because imagine if we only had a single payment option. Then trying to change something in there or adding a field in the front end would require going through all of these steps to understand how is my class instantiated and what is the method that I use to display the fields, then going through all of the extra steps in there to understand what is the thing I need to change to add this new field, instead of just going here, okay, see that I have a view to go to and fix it over there. So be very mindful about what the context of your project is and how you need to work with it to improve your performance. And what about code that's already difficult to extend and maintain? So with the characterization testing, we could adopt safely refactoring of our code step by step. The first step would be to write characterization tests, then find a seam, which is a place in your code where you can safely introduce a change, where you can safely refactor. And then refactor the code, then run the tests again to see if it works as it was supposed to. Now, in my payment class, I didn't show the payment class before. This is a large payment class with a lot of methods for managing the payment that had a switch case to decide which method to call. So instead of relying on that switch part, what I decided to do is focus on finding a seam, which is, okay, in the constructor I can create some strategy pattern to decide what processor to instantiate and use for my particular payment. And then, in my process payment, I just add this line of code over here, where depending on the selection, I will call the proper payment method. Just like we did with our code where we had the clean slate, but over here we need to work with legacy. And then when we work with legacy code, we have tight deadlines, so not always we have the luxury to focus on refactoring, and management never allows it. So how do we navigate that? Again, we follow open-close principle for all of the new functionality. We test the new code, and then we sprout or wrap, which are techniques for extending legacy code with new code which is properly written. I will just show this in the code. So this is how the process payment looked like originally. So what we want to do here, if I'm about to add a Wise processor, for example, I will just sprout this method over here, add this processor as a single one because I don't have time to refactor the whole code, and then call it at the bottom within the legacy code. Now, I'm following the same structure that we had before, but all of the new code that I write is tested and written properly, so I don't just add more bad code in an already poorly written class. I add good code following what I have at the moment. The wrap technique on the other side, it suggests that we remove all of the existing code in another method and then wrap it in a new one where we call something else before and after it. For example, in our process payment method, which was named process payment earlier, we would replace it with process payment legacy, having the exact same implementation, and then in process payment, we add something else before it. This is our original legacy code, and something else after it. So all of the dependencies throughout our code base will still rely on the same function name, but something else will happen. Again, all of the code that's called before and after is well written and tested, and we can follow all of the best practices with everything that we add without affecting our legacy system so much. Before I wrap up, a Laraca series on this topic is coming out in a month, so if you want to dig deeper, I encourage you to check it out. It has more details about everything I just went through. But I want to leave you with this. So your management might not invest time in refactoring. They might not know the impact of good code on the value they create for their users. And it's sometimes difficult to fight it and to say, okay, talk to them and you'll find yourself your way around it. So a better approach might be to just step back and think, okay, what is the thing that I can do as an individual to continuously improve this so over time we get a much more solid system. So this is what I want to leave you with. 1% improvement every 2 weeks, meaning every sprint if you're following Scrum, would end up with 30% improvement at the end of the year. So it is a lot, but it is a lot if you're focusing on the big picture, not on the day-to-day. Thank you.
I got a question.
Okay.
So, Thoridul, I'm just patching this name, not easy. He's asking, what if the real implementation is wrong, since you adjust your test based on your implementation? How to confirm behavior, such kind behavior in legacy code?
Yeah, that's a good question. Basically, the purpose of the test is to understand the behavior, not to validate it. So you would start by writing tests for verifying what the code does and for them to act as a documentation. From then on, you start refactoring and you see if your test breaks. So that's when you realize there is maybe some hidden functionality, some things that you haven't covered. And over time, you get to a point where you write proper tests that actually catch bad behavior. But the starting point is basically to focus on understanding what the code does and covering its current behavior so that if you work on something, you don't accidentally break it.
Thank you. And you know the guy from the anonymous user. Yeah. That guy is asking, is harder to maintain a team or a legacy code?
Ooh, a team.
A team?
Yeah.
You can't blame the team?
That's not how you maintain it.
Yeah. Please, an applause for Katerina.
Thank you.